Okay, so in our lecture 3, we are going to be looking at shear force and bending moment 2. In our lecture outline, we're going to be talking about introduction, sign convention, computation of reaction, and some work examples as well. Under the introduction, we are supposed to know that support are used to attach structures to the ground or other bodies, thereby restricting their movement under the action of applied load. The type of reaction a support exerts on a structure depends on the type of supporting device used and the type of movement it prevents. Support for plane structures are commonly idealized as either fixed support, hinge support, or roller support, or sometimes even link support. Okay, and from lecture 1, we learned that fixed support has 3 reactions, hinge support has 2 reactions, and the roller support has 1 reaction. Thank you. One of the most important steps in the analysis of structure is the calculation of support reactions. Let's elaborate a bit on the sign convention. Okay, external moment or couples. We have counter-clockwise moment, that is also known as anti-clockwise, and that one is always positive. Clockwise movement is considered to be negative. Okay. Vertical forces. Vertical forces may either be upward forces or downward forces. But if you notice that the force is moving upwards, then it means that it is positive. But in a case whereby it is moving downwards, then it means it is negative, as it has been represented over here. Horizontal forces moving to the right are also positive, and horizontal forces moving to the left are also positive. For inclined forces, we said inclined force should always be converted to their equivalent vertical and horizontal forces. That is using the what? Trigonometric rule. Okay. So if the force is inclined, you have to assume a partial line. Okay. That is going to help you get your opposite and your adjacent, okay, to be able to use your SOHCAHTOA to calculate for that. For this force, sometimes it may try to confuse you a bit, but with the help of the cardinal point, you can be able to remember those, okay? So if you take the coordinate axis, assuming this is your y-axis, okay, which is the vertical, and the one moving in the horizontal axis is your x-axis, okay, which means that from the slide we just read, the ones moving upwards are always positive, okay, and the one moving downward is negative, okay, and also the one moving towards the right hand side is also positive, and the one moving towards the left hand side is also negative. Okay, thank you. So you can assume here to be your origin. You see how it's looking like. Please take note. Please take note that. Please take note that for the vertical axis, they can also be represented as what forces that are moving in the hot y-axis. Okay, and for the horizontal axis, they can also be represented as what forces moving in the hot x-axis. So in a place whereby you see we doing the check, it means that we are considering forces moving in the hot y-axis. And in the case whereby you see we considering all horizontal forces, then it means that we are considering forces moving in the hot x-axis. Thank you. So this is a tabular summary of all what we just spoke about. Okay. So we said that vertical forces are forces or let's say force at Y, or the ones moving upwards are always your positive, and the ones moving downwards are always negative. Okay, because they are force, they will either measured in kilonewton or newton, but please take note that the kilo over here is what? 10 exponent 3. Okay, and the newton is the actual unit. Newton. Forces are measured in newton. Horizontal forces are also measured in newton. Okay, so if you see the K, don't get confused. The K simply means 10 exponent 3. Okay. So forces that are moving towards the left are negative, and the ones that are moving towards the right are also positive. Let's elaborate a little bit on the moment. Okay. For the moment, they are always represented by M. Moment has a unit of Newton meter, or sometimes may be written as what? Kilonewton meter. Okay. Based on the measurement or the measuring rule in which you are using, you may either be asked to convert into either or meters. Thank you. So please take note that forces that or a moment that is moving clockwise is always negative, and a moment that is moving anti-clockwise is positive. So these are the basic steps that you go through to calculate for a support reaction. In your step 1, you conceptualize the problem. That is for the step 1. You have to think about the problem. How many supports does it have? Or okay, that if this has 2 supports, what are the reactions? You consider the reaction. If it's a roller, you know that it's 1 reaction. If it's a fixed support, you know that it's 3 reaction. If it is a hinge support, external hinge, you know that it is what? It is having 2 reactions. Okay. Then from there, what do you do? In your second step, you draw a free body diagram of the structure. Okay. You draw a free body diagram of the structure. And that's where you're going to represent your forces in place of the support. Then from there, you check for static determinacy. Okay. We did that from lecture 1. You have to analyze all of those. And in your step 4, you determine the unknown reactions. In your step 5, you check your computation. Okay. So in your computation, that is when you are going to know whether what you are doing is valid or not. Thank you very much. Let's take a little bit of examples and let's see how we can be able to become history from there. Okay, so let's assume this is a problem. Okay, work example 1. 1, they say determine the support reaction for the beam shown below. So you can see that this is a beam. Okay, and how many? This is a simply support beam. Okay, because this is simply support beams are beams that are either hinged at both end or hinged at one end, and a roller is also used at the other end. Okay, so if we can see over here that they have used a hinge support at A and a roller support at B, what can we note as engineering? Now this is a simply support. Okay, and we know that roller has what? Roller has 1 reaction, and this hinge support has how many reactions? It has 2 reactions. Okay, good. So this is the original problem. Okay, so let's say this is our answer booklet. We are now coming to answer the problem. Okay, first of all, what must you do? You have to write given. Okay, then from your given, you draw the original problem. You can see that what we are having over here and what is in the question over here is the same thing. So in your given, you put the problem over here for 1 mark. Okay, you repeat the problem so that you don't lose this mark. And you write over here original problem. Okay, in your free body diagram, you draw a horizontal line and represent your forces. Okay, you can see we have a 20 kilonewton, 20 kilonewton, as it is as of that. 20 kilonewton, 20 kilonewton. Okay. Then for the support, you can see because this is a hinge support, they've represented two reaction over here. You know that hinge support, one reaction is moving in the x-axis and one is also always moving in the y-axis. Okay, that's why you can see that they are fitting VA, and VA means vertical force at A. HA means horizontal force at A. Okay, and then the D, this means vertical force at D. So you can see over here that we are fitting a free body diagram. So you also do this one additional mark. Both of these will never make you lose 5 marks. So please remember to be able to do this. You can't feel strength of material. Even if you're not able to do anything and you put down your gauge in my brother, you are blessed. All right. Then you indicate your distance. Okay. So what do we do? You know that movements are always taken at supports. Okay. So it means that we can only take the moment at both ends. We can take moments at A and at D only. Okay. So first of all, what do we do? Let's take the moments at A first. And that's why over here we are fitting what? Taking moments about A. Good. So first of all, the first thing you must never forget is your Visa card. Okay. This over here is your Visa card. If you don't write it, it means whatever you are doing, you have not put any rule to it. So you are telling lies. Okay. So this is what? Sum. If you see this symbol, it means sum. So sum of all moments, okay, at A is equal to what? 0. Yes. Sum of all moments at A is equal to 0 because anywhere moment is being taken, no distance is being covered. Hence, for the force over there is going to multiply 0. That's why at the end of the day, you're going to get 0. Okay. Then you have to indicate the rule you are using. Clockwise movement. If you take clockwise movement to be positive, you have to maintain that rule throughout. It can also work. But in this case, because we are taking anti-clockwise movement to be positive, we have to make sure that we will maintain it throughout so that the examiner will know the exact one we are talking about. Okay, so over here, we put the rule over there. Okay, to also indicate that all anti-clockwise movements, you are considering them to be what? Positive. Okay, then from there we begin to make the examiner more history about how far you have learned. Then we begin to take the moment. Okay, so this is uh, 20 kilonewton. We say moment is equal to force times perpendicular distance. Okay, distance is measured in meters and force is measured in newton. So if Newton is going to measure distance, or let me say, if force is going to measure distance, what are you going to obtain at the end of the day? You realize that their units are also going to multiply. At the end of the day, we are going to obtain a Newton meter or kilonewton meter as a unit. So from there, what are we going to do? The 20 kilonewton is going to multiply the 3. Okay, that's why you can see over here they've written what? 20 times 3. Okay, then from there, because this arrow is moving downwards, if you use pencil to follow the direction of this arrow about A, you realize that this is taking a what? This is taking a clockwise movement. Okay. So because this is taking a clockwise movement, at the end of the day, it is going to be what? Negative. Okay, based on the direction at which it is going. That is why you can see they are putting a negative over here. So at the end of the day, you can see that they have put in a negative over here. Okay, good. So from there, what do? We are still at our origin. Our A is still assumed to be our origin. Okay, so we have already taken the moment at B already. What we're going to do, we are still going to stand at A and open our compass to C and then follow the direction. Okay, so if you stand over here and open your compass to here, you know that a distance of 6 meters has been covered. So if you move about following the direction at which it is going, you realize at the end of the day, this is going to perform a what? This is going to perform a clockwise movement. So this is also going to be negative. So you put your negative over here, and what will you do? You multiply the force times the distance, the 20 kilonewtons times 6 meters. Okay. Then what is left? You realize that we also have a different force over here, but this is unknown, and this is what we're actually looking for. So at the end of the day, if we stand over here, okay, if we stand over here, if we stand at A, because your compass, or let me say your origin is still at A, and then you move about following the direction of this, you realize that you are going to perform an anti-clockwise movement, and we say all anti-clockwise movements should be what? Should be positive. Okay. So at the end of the day, what are you going to get? This is going to become plus. Okay. So a distance of 3 plus 3 plus 3 is 9. So a distance of 9 meters has been covered. So the VND is your force multiplying the 9. So VND times 9. Okay. At the end of the day, you equate it to 0. Okay. Yes. You equate it to 0. From there, the rest is mathematics. You really simplify. 20 times 3 is 6. And you put your negative, you put your negative symbol. Then 20 times 6 is 120. You also represent your subtraction symbol. You bring your addition sign. VND times 9 is 9 VND is equal to 0. Okay. After simplifying, I'm going to get VND, 9 VND is equal to 180. You make VND the subject and you're going to get 20 kilonewton. Okay. You're going to get 20 kilonewton. This is what we are getting over here. You're also going to stand at D. Now from there, what do we do next? You're coming to stand at D. This time you're coming to stand at VD. Okay. So if you're coming to stand at VD to take our other moment, then it means that who is going to be the subject of the day? VA is going to be the subject of the day because you have already found out VD. So this guy is going to be the subject of the day. Okay. So first of all, what do? We have to take our first moment. Okay. We have to take our first moment. And in taking our first moment, um, you have to write taking moment about D. Okay, then you repeat the rule again. You say that's what? We are taking all anti-clockwise moments to be positive. And then that's the sum of all moments at D should always be equal to 0. Anywhere you take moment is always 0. Okay, all forces about that point is 0 because no distance is covered and 0 times any force or any force times 0 is 0. Okay, so if you are standing at D now, and D is your origin. First of all, you open to 20 kilonewton and you follow this direction and move about the origin. You realize that this is going to take an anti-clockwise movement, so it's going to be positive. So that's why you can say that they are putting positive over in it. 20 times 3. Okay, good. If you still stand over, if you still stand at D and you open your compass to, if you still stand at D and you open your compass to B, okay, and you follow the direction and you rotate, you realize that this is going to also perform an anti-clockwise movement. Okay, and at the end of the day, it is 6. It becomes 20 times 6. Okay, so that is also positive. That is why you can say the positive have been placed over here, showing that it is an anti-clockwise movement that has been performed. And we say anti-clockwise movement is positive. Okay, then you bring your 20 times 6 over here. What else must we do? If you stand over here with your compass, you are still standing at D this time, and you perform your movement, you realize that the last moment you are going to experience is uh, this is going to go a clockwise moment about um, the D, okay, and that is going to result in a negative, okay, so that is going to be negative that we are seeing over here. Okay, that was about the negative, so this became negative, okay, and then this time this VA is multiplying the whole 9, okay, because we said force times distance. So VA times 9. That's what we are seeing over here. This is equal to 0. From there, we really simplify. 20 times 3 is 60. And 20 times 6 is 120. Okay. VA times 9 is minus 9V, and you put your negative symbol, then you equate it to 0. From there, you will simplify. Okay, at the end of the day, you realize that your VA is going to also be 20 kilonewton. Okay, as this that we have over here. Okay, from there, how do we do next? We have to consider all horizontal forces. Okay, so this time you realize that the rule have changed. Because we say we are considering all horizontal forces, it's going to be what? Uh, sum of all forces. Okay, let's say sum of all forces. Sum of all forces. Sum of all forces. Okay, moving in the x-axis is equal to what? 0. So if that is the case, then HA is also what? 0 kilonewton. Okay, it is a force, so please don't forget to add a unit. Okay, 0 kilonewton. Okay, so from there we come to the check. Okay, if you come to the check, because we are talking about the y-axis, you also indicate your rule. Okay, that all forces that are moving upward should be positive, and the sum of all forces moving in the hot y-axis should be also hot equal to 0. So at the end of the day, what are you going to see? How many forces do we have moving in the this HA is what became 0 initially. Okay, so the forces that are moving in the y-axis, let's all count them together. Okay, let's count all the forces that are moving in the y-axis. And how many forces do we have in the y-axis? There are 4. Okay, and those are VD is 1, VA is 2, and 20 kilonewton at E is also 3. 20 kilonewton at C is also 4. Okay, so VA is moving downwards and VA is going to be what? VA is moving upward and it's going to be positive. This 20 kilonewton that is moving, this 20 kilonewton that is moving downward is also going to be negative. So let's all do it together and let's have a look at something. Okay, so this is going to become VA. Okay, in the check, it will be positive because it's moving upwards. Okay, then what else? Minus 20 kilonewton because it's moving downwards. Then minus another 20 kilonewton because it is also moving downwards. Okay, plus VD because VD is also moving upwards. Okay, so from there, what do we do? We only simplify. We know that our VA is 20. Okay, minus what? 20. Okay, minus another 20 plus what? VD is also 20. So at the end of the day, you're going to get what? 0. If you don't get 0, it means whatever you were doing is wrong. Okay, so this is our final answer. If you point this on a calculator, you get 0. So this is what was done over here. Okay, in this region. So that's why you can say that at the end of the day, you also have 20 minus 20 minus 20 plus what? 20, giving us what? 0. All right, thank you. So let's take some of the trial questions and then see how we can be able to play with them by ourselves. So in the trial 1, let's say this is our question. Okay, so if this is our question, in our answer booklet, what do we do? First of all, we have to write given. Okay, so let's say this is the given. Okay, then after writing the given, you come back to analyze the problem. Come back to analyze the problem. This is also a simply support. Okay, that is loaded uh, at two regions within the center. Okay, so at the end of the day, you realize that it is supported by a hinge support and a roller support, making it to be classified as a simple support. So first of all, we have to draw the problem. Okay, you have to draw the problem and write under it, or at the right hand side of the original problem. Okay, so let's all do it together. So this is the problem. If this is the problem, let's put it back again for an additional mark so that we don't lose this mark. So this is our original problem we are drawing over here. There was A, and then B was somewhere here. So C was also here. Okay. And from there, we realized that our D was also here. Okay. So what next can we do? We can write over here original problem. This is our original problem. Okay. This is our original problem. Then from there, let's come and calibrate it. So here was 3 meters. Here was also 3 meters. And here was also 3 meters. Okay. So let's represent our forces. So this one became 55 kilonewton. And this one also became 135 kilonewton. So from here to our solution. Okay. Then we can put down our free body diagram. Then we put down our free body diagram. Okay. So because this is a hint support, it's supposed to have for two reactions. And because it's a reverse support, it's supposed to have just one reaction. So here is D, here is A. So here the 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 of the vertical horizontal force at A, and this is our vertical force at A. This also become our vertical force at D. Then from there, we can represent our force. Okay, can represent our forces, and the first one is equal to kilonewton. The second one is 155. So this is going to be the vertical horizontal. Body diagram. So from there, what do you do next? You can get busy. Okay. Okay. So you're going to take a moment. You can either take moments from A or B. Okay. So let's start by taking moments about A, and let's see how far we can go. So we start by saying we want to take moments about A. Mhm. So taking moments about A. Taking moments taking moments about A. Okay, so this is taking moments about A. And from there, how do we do next? We put down our Visa card. Okay. Um, so and that is going to become we are we are considering anti-clockwise moment to be positive. Okay. So that is let's put that down. Or anti-clockwise moment to be considered positive. Okay. Then from there we tell him that what sum of all moments. Sum sum of all moments. Sum of all moments about us as if what should we for to be hot. So okay. Okay. So mm, that are calculations. Okay. So let's say if A is our origin, because we are taking moments about A. Let's say if A is our origin. Let's say if A is our origin over here. This A is our origin. Let's say this A is our origin. Okay. So if we are going to be standing over here and taking a moment, it means that the first moment we are going to take is going to we stand over here and open our compass to here. The first moment we are going to take is going to be moving about A. Okay. And if you follow the direction of the arrow, it's going to be what? It is going to be a clockwise moment. And we know that a clockwise moment is what? Negative. Okay. So it's going to be what? 55 kilonewton times 3 meters. And represent a negative sign. So all you need to become negative what? 55 times 3 meters. Not 3 meters times 55. Or we say force times perpendicular distance is equal to moment. Okay. So from here, it means that you're going to be writing negative what? 55 times 3. Okay, brackets close. Okay, then let's go and take the other moment. Now we are done with the first one. So let's go and take the other one. We are still standing at A. Okay, A is our origin. And then if you open your compass to C and you take the moment, you realize that at the end of the day, it's going to go about A. Okay. And because the distance is 3 meters, the distance of what? 3 meters has been covered. Because a distance of what? 6 meters has been covered and it is moving in a clockwise direction. It's also going to be negative. Okay, so it's going to be 135 times 6. 135 kilonewton times 6 meters. Okay. Uh-huh. So from there, they're going to write 135 minus 135. 135 kilonewton times what? 6 meters. Then close the bracket. Okay. Then you come and take the last one. 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 So you are still standing at your A. Your A is still your origin. Then if you follow the direction of this arrow, you realize that this is going to take, let me call it, it's going to take an anti-clockwise moment following the direction of this. This is going to take an anti-clockwise moment. Okay. So it's going to be what? Positive. If that is the case, is going to be VD times 9. Okay, so let's write it and see. It's going to be plus what? VD times 9. Or is equal to 0. Or is equal to 0. Okay, now the rest is mathematics. So you just simplify. Okay, so you repeat your negative symbol. 55 times 3 is going to give you 165. Okay, and you bring your negative sign. 135 times 6 is going to be 80. Also, VD times 9 is going to give you 9 VD. Okay, and you bring it is equal to what? 0 over here. From there, how do you do this? From there, how do you do this? You only simplify. You only simplify. Minus 165 minus 8 times going to give you negative 975. Then from there, you still put your 9 VD or equal to. From here, you only group like things. You only group like them. Okay, from change of subject. So uh, let's move this negative 975 to the right hand side so that it can become positive and we find for VD. Okay, so we are going to get 9 VD is still going to be at which position? Okay, so this is what to what? The 0 there is the 0 minus what? It's now it's going to be positive. If it's moved to this side, it's going to be what? Positive. Okay, so 0 plus 9, 7, 5. At the end of the day, I'm going to get what? 9 VD. This is what? 9, 7, 5. If you divide both sides by 9, if you divide both sides by 9, you realize that 9 is going to take off 9. This now take off this 9. And then from there, what are you going to get? If you bring this out, you are going to get what? VD. You're going to see that you're going to see, you're going to be left with VD is equal to what? 975. 975 all over, all over 9. Okay. If you divide this at the end of the day, therefore, you're going to get your VD to be equal to 1, 0, 8, 4. Kilometers. We are done. Finding for VD. Okay. So now we have to go and take moment about to also find for VE. Okay. Okay. So let's without wasting much time, let's go and find for that too. So from here, this is going to become, so we are done calculating for VD. Okay. So we want to go and find for thing A2. Okay, so it means that this time we have to come and take our moment at D. Okay. Mhm. So let's also make a little elaboration on that and see how more history we can become. So let's say that this time we're going to be taking the moment at this side. Okay. Let's say this time we're going to be taking the moment at this side. Okay. So it means that if we stand over here and we open our compass to here, 135 is going to perform a what? An anti-clockwise movement. So it's going to be positive. Okay. So it's going to be positive 135 times 3. Okay. But before that, hot must we do? We have to go and write what? Taking moment about D. Okay. Before we can get certified. So let's practice that. So over here and write taking moment about D. Okay. So taking moment about D. So this is taking moment about D. Taking moment about D. Taking moment at what? D. Taking moment at D or taking moment about D. It's all the same thing. So what do? You bring your hot, the rule you are using. Okay, that's if you are saying that hot, all forces that are moving anti-clockwise should be hot positive. Then from there, we say that what sum of all moments. Okay, sum of all moments at D will be equal to what? Will be equal to 0. Okay. The first one, which we just analyzed, you realize that this one is going to perform a hot an anti-clockwise movement about D, and a distance of 3 meters is covered. Okay, so gradually this is going to become positive what? 135 times 3. 1, 3, 135, okay, times 3. Then you close your bracket. Then you close your bracket. Then you're going to take the other moments also. Okay. You're going to take the other moments also. So this one is also going to become, this one is going to become the moment of 135. This one is going to become 55. Okay, if we are still standing at D, you follow the direction of this arrow, you're going to take a moment of what? You're going to take an anti what? You're going to take an anti-clockwise moment, and at the end of the day, it's going to 55 times 6. Okay, 55 kilonewton times 6 meters. Okay, and it's also going to be positive. So from there, what are we going to write? We're going to write plus 55. Okay, 55. 55 times 6. 55 times 6. Okay. 55 times 6. Then minus what? Minus what? Uh, your VA. Okay. Because you realize that the VA is also going to perform what? You realize that the VA is also going to perform a clockwise movement. That is why we are getting a minus. Okay. The VA is also going to perform a clockwise movement. The VA is also going to perform a clockwise movement. This time we are done taking C and B. We are going to take the last one, which is the A. So we follow the direction of this. Yeah, this is going to take a clockwise movement. Okay. So at the end of the day, it's going to become what? Minus VA times 9. Okay. Okay. So it's going to become minus what? VA times what? 9. Okay. Then let's consider the horizontal force. Okay. Because we are taking moment at this side. Because we are taking moment at this side. Because we are taking moment at D. Because we are taking moment at D. You realize that HA, which is a force, can be considered. This time it's not going to be 0, so we can also include it in our calculation. So because it is moving towards the hot right hand side, it is going to be hot positive. It is going to become plus HA times 0. Okay. All is equal to 0. Now the rest is mathematics. Okay. So we just simplify. 135 times 3 is going to give you 405. Yeah, so 55 times 6 is what? 330. So then you bring a negative sign. 28 times 9 is going to give you 9 plus 0 equals 405 plus 33. 330 is equal to what? 735. And then minus what? Power 9 VP. Okay. So from there, what are we going to get? Is equal to what? 0. From here, we can group like terms. That is, we maintain the what? 7, 3, 5. We maintain a 7, 3, 5. Then after maintaining the 7, 3, 5 is equal to what? 0 plus what? 9 VA. Because if 9 VA moves to the right hand side there, if it causes the equal to sign, it's going to become positive. Okay, that's the rule of change of subject. So at the end of the day, what are we going to be left with? I'm going to be left with 735 is equal to 9 VA. Okay, let's divide both sides by 9V. We divide here by 9VA. And if we divide here by 9VA, we divide here too by 9VA. At the end of the day, what are you going to get? This will cancel this. Okay. 9 will cancel 9. Okay. So you divide both sides by 9. Okay. Then from there, 9 will take care of what? 9. So from there, what are you going to get? We're now going to be getting what? Our VA, or let's say we're going to be getting 7, 3, 5, all over 9, which is equal to VA. Okay, at the end of the day, you realize that we're going to get 7, 3, 5 divided by 9 is 81.66. Because the other one, you left it in 2 decimal places. Please remember to also leave this one in 2 decimal places. Okay, so this is going to become what? 81.67. Okay, kilonewton is equal to what? VA. So we can finally say that what? Therefore, therefore, our VA, our vertical force at A is equal to what? 81.67 kilonewton. From there, what do we do? We're only coming to consider all our horizontal forces. Okay, okay. So we come here considering all horizontal forces. So we come over here. So we say that we're considering all horizontal forces. Considering all horizontal forces. Okay, so what do we do there? Let's put our arrow over there. Okay, and that is going to be, we want to use this rule. Okay, this is the sign we are maintaining because we are using positive. Let's use positive throughout. And that is now going to become sum of all forces about what? Because we're talking about the horizontal, and it's going to be x. About forces to equal to what? 0. And if that is the case, this your HA that you are seeing over here is 0. Okay. So if that is the case, this HA that we are seeing over here, this HA that we are seeing over here is 0. Okay. So therefore, our HA is going to be 0. Okay. So therefore, we are saying all horizontal forces, sum of all forces about x is equal to 0, then which means that therefore our HA, our horizontal force at A is equal to what? 7 kilonewton. We are done. What do we do next? Let's come and consider all the vertical forces. Okay, so from there we come over here. Okay, what are some of the vertical forces we have over here? Let's all take a look. How many types of vertical forces do we have over here? You realize that we have a total of 4. Okay, this is 1, 2, 3, 4. Okay, here's the 4th one. We have 1, 2, 3, 4. Okay, so we come and write over here, considering all vertical forces. Or in other words, let's say checks. So here is going to be checks. Okay, and because the check normally talk about the vertical axis, let's still maintain this rule for positive. That's all forces that are moving upwards. We consider them to be positive. Okay, all forces that are moving upwards, consider them to be positive. Then from there, you can say that sum of all forces, okay, sum of all forces at y should be equal to what? 0 plus is equal to 0. Okay, so if that is the case, what else can we note? All those forces that are moving in the y-axis, we will bring them and classify them. Okay, so the first one is VA, and it is moving upward, so it's what? Positive. Okay, so we are going to have what? Positive VA. Okay. Then the second one was what? B, and it is moving downwards. Because it's moving downwards, it's going to be what? Minus 55. So this is what? Minus 55. Minus 55 kilometers. Okay. Then what are that one? The 135. 135 kilometers until you realize that it is moving downwards. So it's also going to be negative. Okay, so minus 135. 135 kilometers. Okay. Then the last one is Hindi. Okay. Plus Hindi. Plus Hindi. Is equal to the. So at the end of the day, you only substitute your parameters and then find for an answer. Okay. So what is the answer you had for VA? The answer we had for VA was the answer we had for VA. We had what? 81.67 kilometers. So 81.67 kilometers. Let's quickly put that down. 81.6 kilometers. So this is 81.6 kilometers. 81.67 kilometers. 81.67. Okay. And then what was the next one? Let's bring that minus 135 minus 55. Okay. We're using the minus 55, then minus 135. Okay, plus the VD. And what was the answer for the VD? It was 108.33. Okay, so then we come out 108.33. Okay. At the end of the day, if you punch all of this, you're going to get 0. Okay. If you don't get 0, it means whatever you did is wrong. Okay. So that is it. And please, and a very big please, try and meet me in person. Okay. So that we can be able to solve more examples. Uh, this is actually a practicalized aspect of the course. Okay. But if it's being done virtually and it's not being practicalized, you realize that you may understand today and forget tomorrow. Okay. So please, and a very big please, try and organize yourself and then meet me in person so that I can take you through before the exam because you cannot skip this in the exams. You really need lecture 3. Lecture 3 is your bread and butter for this semester in strength of material. If you don't understand anything at all, at least you have to understand lecture 3. Thank you very much. You can see me in group, in person, one-on-one. In case you have any challenges or you wish to understand certain things that confuses you, I'm always available. You can text me. Thank you very much.